the world. Nice to see so many brave souls today in the attendee list. It is going to be a heck of a talk. So definitely hold on to your hats because, yeah, this should be fun. Real quick before I start, I do have a Q&A pod up above where the chat is. If you have questions, please drop them in the pod. If I have time during the session, I'll go ahead and grab those. If not, I'll try to get back to you through email. You'll also have access to my email and everything at the end of this. This is being recorded, so if you have to head out a little bit early, that's fine. You'll be able to review it probably tomorrow or the day after on our YouTube channel, which is also listed at the end of this. And Dave, yes, I can sing. I didn't say I could sing well. Point. Point mark. One lyric from Spiderweb. Wow, yeah, how does that go? Anyway, maybe later. We'll see if we have time at the end. We won't have time. Okay, so I am going to go ahead and get started. Welcome to ColdFusion Fundamentals, Object-Oriented Programming and Modernizing in Adobe ColdFusion, Modernizing Your Legacy Code. We're going to be talking about a lot of things. My name is Mark Takata. I am the Global Senior ColdFusion Evangelist for Adobe ColdFusion, and I am just going to get started. What are we going to be talking about today? All right, we're going to start off pretty basic, right? So I'm kind of assuming that, you probably have heard of object-oriented programming. I mean, you came to this talk, so, I mean, unless you just love me, that's really sweet. You probably want to learn a little bit more. And is that a Republic Lat in the background? That is not a Republic Lat in the background. That is, you're probably talking about that. That is the Razor Crest is what that is. So from the Mandalorian. So why do we want to use object-oriented programming? We'll kind of dive into that. We're going to go into core OOP concepts. And then really dive in. We're going to talk about what encapsulation, abstraction, inheritance. I mean, all of those things are in CF, polymorphism. And then we're going to talk about how you use it in ColdFusion. So a lot of this is conceptual. It's kind of high level. And then we're going to dive into what that looks like in CF. And then what it doesn't look like what is not OOP, but some people think it's OOP. Okay. Then we'll drop a little bit into some pattern concepts. We're going to talk a bit about MVC, again, at a fairly high level, as well as singleton patterns. And then I'm going to run out of time. I can just promise you that right now. But I do have 2 sites, and we're going to go and say, okay, this is what a legacy site looks like. It might look a lot like what you have right now. And then I'll just, with the time I have left, I'll show you a couple of places where I fixed that. The nice thing is that site is already up on my GitHub, and it is really, really well documented. So you can go through there, and there's 2 sites. There's a legacy site and a modern site. Everything shows you where it's wired, what the concepts are behind it. It's really, really good. So without further ado, what is object-oriented, right? What is object-oriented programming? Well, so really it's conceptual. Right? There's not I'm going to download the OOP library, right? So this is a conceptual way of organizing your application programming around something called an object. Okay, so what is an object? So an object is essentially an abstraction. It combines the state of something and the behavior of that thing. So instead of one giant code base or one big page or a series of big long pages that are top-down procedural, and that's sort of the evil mirror universe version of OOP, is the top-down procedural site where everything is all in your page. We build the systems from a bunch of different parts that all work together, talk to each other, and they work in concert towards getting, whatever your functional need is for the particular piece of application that we're talking about. So as an example, right, you might have a user object. And that user object has the person's name, their role, their access permissions, whether they're even active, right? And by the way, just really the concept of an object and the concept of normalization of databases echo each other a little bit, right? It kind of sounds like, oh, you're talking about a store, a user store, a database with a user object in it. Well, sort of, right? So we're abstracting that away. We're abstracting away this concept of being able to hit that because your user database probably doesn't have an address field because that would be bad, right? We want to normalize that out to addresses that are linked because you can have multiple addresses and number, right? Same with phones, but you don't want to expose that. So the object would already kind of understand that and be able to add to that. An order object might have items, total statuses. Report service object might use other services and other objects to build reports. And we'll talk a little bit about how that works and what that's called. So why do we even use OOP? Like, because it's cool, because it's like OOP, OOP. It's like a really cool thing. Well, yes, but also it just makes code easier to maintain and understand. And I know you're like, does it though, Mark? Yeah, it actually really does. When you get code that's, tens of thousands, hundreds of thousands, or even like close to a million lines of code, and you've just got stuff that is in a bunch of pages and it's all mixed in and you have no idea where things are. And by the way, I have seen that, not naming any names, but you know who you are. It makes it really, really tough to actually go in and maintain it. Not to mention, trying to hire someone to actually maintain that in the modern era is really, really, really difficult, right? But there's also like functional reasons for it, like you're grouping related logic together. That makes a lot of sense. You're using the dry concept, like not repeating yourself. You're reusing components. It makes it a little more efficient. When you need to update something, you can really just update it in one place, right? So that's the maintainability level. Also, it makes testing a heck of a lot easier because you can set up smoke tests for your components, for your objects. You can call them from your tests instead of trying to like go into a page and just test the page loading and trying to deal with that. You can just say like, well, does this actually do what I need? You could write a bunch of test-driven development type of things. Makes that way, way easier. I mean, it basically makes it possible. Can't really do it that way with top-down procedural. I mean, if you can, God bless you. I don't know how you do it, but I've never been able to pull that off respectfully and actually in a way that works. And really, the end goal here is object-oriented programming allows you to create these really, really huge applications. So applications with tons and tons of different functionality, having like multiple people working on them, all of that, without everything collapsing into just madness and chaos, right? So it turns a pile of files into a system of individual responsibilities. Okay, so there's three real concepts that sort of underlie object-oriented programming. Obviously, there's more to it than this, but these really grab it at its core. So the first one is abstraction, right? It's hiding complexity behind a simpler interface. And when I say interface, I don't mean a user interface, right? Because this is all in the background, and I don't actually mean the interface concept. That's a different talk. What I mean here is you're hiding the complexity behind something that takes in and puts things out. It ingests and it emits. Sometimes it doesn't even emit, right? But it does a thing. Inheritance. So allowing one class to inherit or extend another when that relationship makes sense. And I'll talk a little bit about inheritance versus composition. Okay, those are two different but related concepts, and we're gonna like dive into this. And then polymorphism. So polymorphism has a bunch of different names and concepts related to it, but really underlying it is different objects can respond to the same method name in different ways. So you could have let's say a process order, right, object. And that process order object would act slightly differently based on, let's say, um, the type of like whether it's a credit card or some other way of payment. Like the payment type coming into it would be different coming from different places, right? Or maybe you have a store that you purchase things from and you can choose to either have it shipped or picked up, right? Those could use the same objects, but then they would respond in a different way depending on what was put in. Those are just examples, right? So what is this in Cold Fusion, right? Well, so encapsulation in Cold Fusion just means CFCs, right? CFCs can own their own variables and methods, and the implementation details stay inside, right? They're self-aware, they're self-encapsulated, right? They're sort of self-contained, and other code interacts with those through exposed public methods, right? So this right here is a very, very, very simple of encapsulation. Sorry, it's a little like weirdly it's weirdly wrapped, but this is a component. There's a couple of variables. They're hard coded. Mark and Takata. Right now, there's a public string, gets the full name, and it outputs my name. Now, this is like baby's first encapsulated. What this should look like, and I know you can't read that because it's tiny, but if you were to kind of go through this, there isn't hard coded things here. There's functions that initialize each of the variables. There's things that build pieces. There's things that take those pieces and put them together, and then there's things that emit them. So this is more of what a real life thing would look like. And obviously a couple of lines of code, way more, right? That doesn't matter. None of that matters. But what I'm trying to say is that's kind of how encapsulation works in CF. Okay, abstraction. The caller doesn't need to know every single internal step, right? We're abstracting away stuff. We're taking the complexity and we're putting it behind a wall that no one else has to, know anything about. Whatever happened, where the sausage is made, people don't need to care about that. You're just exposing a clean action through the method. Because let's face it, there's probably a lot of like algorithmic stuff. You're probably cleaning stuff. You're definitely doing some security, right? Right. You're making sure any input that's coming from insecure places is being, cleaned or blocked or whatever. And then you're going to either drive that to a database, you're going to emit it back out to the page, whatever you're going to do. But none of that really matters. What the caller, this function call that you're calling, really cares about is that you're putting in a couple of variables, a struct, right? A form object, JSON, whatever it is. That's all it cares about. And it's going to go in there. So order service.place order might validate data, save order, send email, and update inventory, and it just calls the one method to do all those things behind the scenes, right? Be careful about making things too complex, by the way. But okay, so what is inheritance and polymorphism? So inheritance is when one class extends another to gain some of its power, right? Um, but then potentially override some of the behavior, right? So one example could be like set name, and that name is first and last name. Well, what if we needed something else called set full name or set name and nickname and needed a third field? Well, you don't want to rewrite the whole thing necessarily, right? Because you're already doing a lot of the stuff in there. But you could potentially inherit some of the functionality of set name and extend it. Now, we're going to talk a little bit in a second about why a lot of people don't necessarily use inheritance and they use something else, but we'll talk about that. Polymorphism, different classes present a similar interface, but they behave differently internally. Okay, that's another concept there. And then, so here's some example concepts, right? So Stripe gateway.charge and PayPal gateway.charge. It's the same method idea, but they're different implementations of .charge. Okay. So here's the note, and I've been talking about this. Composition over inheritance. These days, in the modern way of doing things, we prefer composition over inheritance unless inheritance is very, very clearly and cleanly the way to do things. All right. And the thing is, here's sort of the reality of the situation. None of us are mind readers. None of us are future readers, I should say. We don't know the future. We're not prophets. Unless you are, in which case, apologies. And by the way, can you DM me tomorrow's lottery ticket numbers? Thank you. But so we might know what's good today, and maybe inheritance works today, but it won't next year or next month or whatever. So composition is often a better way to go. Wait, you're like, okay, Mark, you've said composition like 20 times. What the heck do you mean composition? Well, composition means building an object by giving it other objects to help do its job instead of inheriting directly from an object, right? So if you have a build first name or a save first name, you might have different objects that take in all of those pieces. You might have an object that writes to the database. You might have an object that trims things, right? You might have a bunch of different things that come together and then they output a single thing out the other end. Now, hopefully you understand that the difference there between composition and inheritance, right? So inheritance, a class is a kind of, it's a version of another class, whereas composition, it has a thing or things that it uses to get the job done. So why? Why would you do that? Well, the reason why is that with inheritance, you can create this long chain and any change up the chain will get echoed down the chain, which could be good, but it also could create a situation where you're not really aware of downstream effects. So, so that's an issue. So a lot of times we just build all the pieces together and put it into one, and Bob's your uncle. So what is object-oriented programming in ColdFusion? Well, you probably already guessed it. It's CFCs. It's components, right? OOP usually lives in CFCs. CFCs, obviously, they define properties, methods, dependencies, initialize things. And they're building blocks of models. We'll talk about models in a second. Services, repos, utilities, controllers. We'll also talk about controllers, wink, nudge, hint, hint, say no more. So, you can often have things like user, order services, product gateways. So all this is kind of sounding a lot like objects, right? Well, yeah. Components are often called objects or classes in other languages. So there you go. What isn't object oriented? This is a big one because I've seen this. I've seen people go, we modernized our code. It's all object oriented. And I go and I look and they just kind of took what they had and they dropped it into a CFC, but it's still basically like top down and it's doing a bunch of stuff. Yeah, don't do that. You got to rethink some of the architecture. You have to abstract. Like they don't abstract anything. They'll hard code a bunch of stuff. Um, and it's not really permission to make 400 tiny little objects. Like over normalization actually can happen here. The same way it can happen in a database. You can over normalize everything. It's not really permission to make like hundreds or thousands of little objects, all of which kind of then assemble together. Like that is composition and it is object oriented, but it's also not a good idea. So a lot of it is just really it's logical thought. It's thinking through a problem and doing what you need to do to make something manageable, maintainable, long term. Um, Good object-oriented programming is it's about the responsibility of each of the objects for what they do inside of your application and the design of those objects, not just the syntax or the scaffolding or the look or having .cfc at the end of it. That's not what it's about. A badly designed OOP system is still badly designed. It's just object-oriented badness. So don't do that. All right. So a lot of people mistake MVC for object-oriented, right? I say, "Oh, do you know how to do object-oriented code?" They say, "Yeah, yeah, all of my stuff is in MVC." And I'll say, okay." It's like saying, "Do you drive a car?" Like, "Yes, I bought tires last year." I mean, that those tires could be for a car, sure, right? But they also could be for a bicycle or I don't know, a dump truck or something else, right? Like, so what MVC really is a pattern. It's an architectural pattern. It's a way of putting your code into a particular set of scaffolding that ends up working together to create an application, right? It's a separation of concerns, which sounds a lot like object-oriented programming. The two are related. Okay. MVC stands for model, view, controller. Three separate pieces. And by the way, this is not the only architectural pattern out there. There's a ton of different ones. I'm not saying this is the one you should use. This is just a very common one. It's been around for a long time. There's a lot of frameworks that you can download today that will help kind of do a lot of the underlying wiring for you. Um, and by the way, the code samples that I'll be showing you later do actually go from a top-down procedural, kind of mishmash junk legacy style to an MVC. But I did it in a way that I want none of you to do, which is I wrote my own MVC framework. Yes, bad. Don't do that, please. There's stuff out there. There's ColdBox, there's CFMVC, there's Wheels, there's stuff that you can use. The reason I didn't use those, by the way, is because it's much easier to see what it's doing when I wrote it myself and actually wired it up myself. Like, but there's no, I mean, it works fine. You can steal it if you want, sure. Yeah, go to town. It's very functionally slim. All it does is the MVC part. These other frameworks do a ton more. So anyway, back to back to what I was talking about here. So what is a model? A model is the data and business logic. It's the data access layer, right? It's sort of the algorithmic stuff. The view is the presentation layer. It's the user interaction layer. It's what the person sees at the other end. It's the person who's interacting with your site sees. And the controller requests is the request handling, is the coordination between things. It's controlling the way things work. It's kind of like an orchestrator in a way. And so usually the way things go is the user request comes in, it goes through the controller to the model, and then it goes to the view, which drops into the browser as a response. That's kind of the common way that works in an MVC framework. And by the way, there's a ton of there's MVVM, model view model. Like there's all sorts of different kinds. So anyway, um, and as you might have imagined, object-oriented programming and MVC work really, really well together, right? Object-oriented is the design style, MVC is the structure. And having objects helps each layer stay focused on its own job. So you might be asking, can you do MVC that's not object-oriented? Yeah, unfortunately, I've seen it. It's not good. Don't do that. It makes it really hard. I mean, especially when you start dropping into some of the frameworks, they're expecting objects, like they're expecting stuff to be abstracted properly and stuff. But you can see, I think maybe even in my code, there's places that I could have abstracted better and done better object design. But the idea behind mine was that it was taking what is supposed to be like a 20-year-old project, really, really poorly designed legacy code, and taking that first step towards abstracting it away and turning it into something that's object oriented. But OOP gives us the building blocks, and MVC gives us a way to arrange those into an application. So what are all the layers in MVC? Okay, model. So this is, like I mentioned, it's the data and the business rules inside of your app. And this is the place where the objects sort of want to live in, right? Because often when you're abstracting into objects, it's because they're doing things, and the model layer does a lot of things. So models are often CFCs, and you'll see that in my in my code. They're entities, they're services, they're repositories, gateways to things, right? So like user order, product service, things like that. Now you want this is an abstraction in and of itself, right? Because we're abstracting away all of the business stuff away from the stuff that the browser can see, right? You don't want the browser doing anything with models, this kind of back end stuff. The view is what gets shown to people, and in ColdFusion, it's I shouldn't say often a CFM. It is a CFM. It's pretty much the CFM. I guess in some cases, if you're using like HTMX and pulling in like pieces to build the view, I guess this could be an HTM, but the stuff that's doing the heavy lifting at the end of the day is going to be a CFM. And this is displaying data. It's not really a lot of business rules, right? So some good behavior, good quotes, like rendering values that have been calculated, right? Looping through data and showing it on the screen in whatever way it is, whether it's in a graph or tabular data. Applying formatting to raw data. So maybe it's taking like JSON and showing that in a way that makes sense to human eyes. You can scroll through a pagination, things like that. Um, and even potentially, you could put some logic in it, like conditional display logic. That's fine. Like pagination, ordering, right? That's fine to be in the view layer. And by the way, this is still potentially being rendered on the server, right? This is not JavaScript stuff that's being rendered on the browser, although it could be, right? Depending if what you're in. Now we're talking about ColdFusion, so it's on the server, right? In JavaScript, things get a little bit blurry, and I don't want to go down that rabbit hole too much. But if you're doing something that's running on Node, but you have a really powerful front end, where do you balance that, right? And I've seen a lot of arguments happen architecturally because some folks want to do like ordering behind the scenes and do server side rendering of it. Other people want to do it on the front end because they want a little more control over it. There's always performance drawbacks to each of those, right? But in this case, like I said, we're in CF for the most part, unless you're using a front end and pulling it through an API, which you probably would be if you're modernizing your stuff. Then like you have to make that decision, like how much data are you actually pulling down and where you're going to do that type of stuff, the conditional stuff. But in any case, bad behavior would be database access from this page, like directly, like I'm just going to pull this and drop it into the view, like right in the view. No, don't do that. Workflow, so decisions on how the actual logic is going to work. Like complex rules, I know that's a really like high level sort of vague thing, but anytime you're doing anything complexly that has to do with like algorithms or like math or a bunch of really really deep programmatic stuff, that does not belong in the view. The view should be as simple as you possibly can make it, is a good rule of thumb. And then there's the controller. The controller accepts input and it calls like the service layer, the model layer, and it chooses which of the views you're going to take the data and render them into. So basically, these things work without becoming the home of all the business logic. The logic is done off in the model. The controller just decides where it's going to go. So there's some programming happening here. There's decision making. There's workflow decisions that are happening here. They're just abstracted away, and you're not doing a ton of algorithmic stuff in here with the actual data, right? So, for example, you might receive a request, do some validation, maybe make sure things are okay. You're going to call a model, order service out place order, and then the result of that is going to get passed to a view, right, or a response, whatever it happens to be. It might be an API that then gets dropped into React or something, right? But the key thing here is we're orchestrating. We're not dominating everything. We're not doing all of the heavy lifting through the controller. So here's a sample flow, right? So the browser requests an endpoint, orders save. The controller gets that request and it calls order service because that's what's been set up to handle this particular thing. Order service talks to the object called order and the object called order repository composition. And the result of that gets thrown back to the controller, and that's passed to a view, which then renders out a visual result to the user interaction layer, which then ends up getting pushed to the browser. And there you go. So this is a sample way of an object-oriented methodology to run through a save order. Okay, we're going to switch off MVC for a second. And as I mentioned before, MVC is a design pattern for building applications. It's an architecture scaffolding method, basically. Now we're going to go into a different design pattern called a singleton. Now, a lot of you may or may not have heard of singletons. I actually heard of singletons the first time in Star Trek: The Next Generation when one of the binars that had lost its partner was called a singleton as a slur. Fun fact. It's not a slur, it's a design pattern. And what does it mean? It means it's one shared instance of a class that's used across the application. It's often used for shared services that are stateless, right? So like a configuration service, a logging service, a caching service, something that's shared. Keep in mind, this is a supporting pattern. It is a piece of your architecture. And you can have singletons that live inside of MVC, and you often will. This is just a different object-oriented, adjacent design pattern. But it's never going to be the entire architecture of your site, unless your site is literally like one tiny service that does almost nothing, right? And that's not really an application. So in plain English, what does that mean? Well, you create one instance of something and you just reuse that instead of recreating it over and over, right? So let's say you want to log something. You've got a config service that reads your settings once and then exposes those everywhere, right? Or one logging service that handles logging for the whole app, right? You've got multiple controllers. They all call the logging service. It's all shared across all of them. And that one thing does all the logging. It's just found in one place. Sounds pretty simple, right? Well, like anything, there's pluses and minuses, right? The benefits are it's very dry, right? You're not repeating yourself. You're creating the object once and just reusing it. That means performance benefits, right? It centralizes logic that's shared across multiple use cases. Also good, very maintainable. It works really well for stateless services. That's a big point here. This should be in bold. It works really well for services that don't maintain state across. Like when you log something, you log and you're done. You're using it. You're picking up the shovel, you're digging a hole, the shovel goes back to where it was before. It doesn't keep the dirt in the shovel. And it works really well with dependency injection frameworks. Those are a little bit out of scope for what we're talking about today. Maybe I'll do another talk on dependency injection if anyone's interested in that. I will point out DI is available basically in all of the different MVC frameworks. It works really well with those. So if that's something that you're interested in, you can pick up, ColdBox, and ColdBox I think has Wirebox as their dependency injection framework. We're still working with porting over the dependency injection into CFMVC, but you're welcome to still use, even though it's not being directly maintained, you're welcome to use F1, and they have a dependency injection framework called D1. It's just out of support for now. We will be moving over that into CFMVC. And I believe Wheels also has some dependency injection stuff. If anyone's using it, if everyone's here from there, let me know in the comments if that's true or not. Okay, risks. These are pretty nasty ones. So yeah, definitely want to pay attention. The risk is it can become a hidden global state. And it's really, 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 really tempting to do it. Don't. Global states are bad for a reason, right? You don't want to have those in your app. And I'll talk about that a little bit in a second, especially when they're hidden behind the scenes. I mean, that's even worse, right? When you don't know that it's back there. It can make testing super hard if it's tightly coupled with states, especially, right? You want this thing, you want to know that this thing is ready to go, empty. You want to know that your cup is empty and washed before you put your tea in it. Um, and it can really create some strange is doing a lot of heavy lifting. Nasty is the word I probably should have used. Bugs, if it stores request specific or uses specific data for more than just the time that it's alive while it's doing the thing, right? Um, what kind of bugs am I talking about? Well, data going to the wrong person is one thing. The wrong data getting written, things like that. Like race conditions can occur if you're allowing it to have any state really at all. Stateless singletons are very useful. They're very helpful. They're wonderful. A stateful singleton, I'm not going to say it's always trouble, but it's always an opportunity to cause yourself a heck of a lot of trouble. And so I would avoid that as much as possible. All right. So we talked about three concepts so far: object-oriented programming, MVC, and singletons. What are they? Let's just do a rewind here. So OOP organizes your code. It organizes it into objects that are focused on a particular set of tasks or task. MVC is a separation of concerns. It takes the pieces of your app and puts them into logically separated areas. Those areas could use object-oriented and probably should use object-oriented concepts in the way the objects and the functions and the classes work. And a singleton is a way to share a selected service statelessly, hopefully, and cleanly across an application. So how do you want to put how would we want to put this into ColdFusion? Well, we're going to use CFCs to separate the concerns cleanly. So that's the object-oriented side of these things. We're going to potentially use MVC to separate things out into models, services, controllers, views. We're going to try to keep controllers thin. This is something I didn't really mention before, but like you don't want just a ton of orchestration happening through a controller. You want them to be separated out so the moment you drop into them, you know exactly what it is that they're doing. And even thin controllers can be a lot of lines of code, right? That's why you want to do this, because you can get a lot of complexity in something that really doesn't do all that much. Keep your views focused on output. If they're doing a bunch of calculations and all kinds of programmatic things that don't have a direct effect on the user interaction layer in terms of what the user sees, probably doing it wrong. Take that functionality and push it out into a model. Use singletons for shared, mostly, always, stateless services. So service that's used and then done. And use it for services that are shared across multiple things, right? Like logging is a great one. Error handling is a great one, right? You need that everywhere. Use one thing. But don't let patterns become ceremonial. right? We're not doing this because we want to hand this off to someone and tell us how beautifully pattern we created, like how wonderfully. I mean, sure, come to Summit and show me your site. I'll pat you on the back, right? Like, but that's not the reason. The reason why we're doing all of this is to create much more maintainable and understandable and long-term viable applications. That's why we're doing all this. Like in 5 to 10 years, we can look back on this and still be able to maintain it. We're not going to be in this state where like everything is a nightmare to try and find, oh, like where's this thing happening? Well, it's happening in 75 pages, Mark. Oh, good. We get to update that in 75 pages. Like, no, it's happening in this model. We fix it there, we fix it everywhere. And by the way, like so we've made some changes in the recent past in ColdFusion in terms of how scoping works, and often I'll get people kind of complaining about how much work it's going to be to fix all of that. And when you tell me that you've got 40,000 instances of a particular thing being pushed out, that tells me that you're not programming in an object oriented way. Right. And I hate to use the term legacy. I mean, it comes up a lot because a lot of times people conflate legacy with the platform. Like ColdFusion is not a legacy platform. We update it all the time. You can program in a hyper modern way today in ColdFusion, but often the code, the architecture, the way that it's been put together is in a legacy way. Right. So that's what we want to move from that to the modern standards. We don't need to change platforms or languages. We do it all in ColdFusion. And honestly, when you see modern ColdFusion code, I've shown that to people and said, "What language is this?" And they're like, "I don't know, any language, right?" There was it Python. What is this? Like, they might not identify it directly as ColdFusion. They're like, "Oh, it's JavaScript." Often, like, "Oh, it's stuff. This is Node." And then I'll be like, "Really? Does Node have this member function?" And they're like, "Oh, wait, no. What is that?" Right? Like, is this a some weird framework? And I'm like, yeah, you could say it's called Fusion. Doesn't run on Node. It runs on Java. And then finally, the big thing here: patterns should make the app simpler to not just reason about, but to understand, to explain. When you need to make a change to your app, these patterns should help you be able to take that piece, say that piece used to do this thing. Now we want it to do these additional things. How are we going to do that? And allow you to like just put that up on a board. Say, okay, well, if we extend it, if we use some composition, we add a few more models here and we kind of connect those together, then we'll get what we want. Versus, well, we're doing this thing in a bunch of different pages. They're all at the top in tags. We're going to have to go and either like, God help me, do like a search and replace of things, or these days probably we just ask AI to do it, and just pray that it does the right thing, and doesn't decide to break your app completely. Um, but none of this should make it more complicated. It should be the opposite, actually. Like you should be able to go through and actually explain piece by piece logically from end to end how your application works. Patterns help you do that. Object oriented programming actually helps you do that. All right, so that's enough of the PowerPoint. Now we get to the fun part. I have 15 minutes. Oh my gosh. Okay, hold on. All right. So this is the GitHub site. It'll be listed on the end of my thing. If you want to go and grab this site right now, you can. It's up for people. It's visible. It's downloadable. And I'm just going to real quick go over what's in it. All right. So it's under webinars, modernizing CF. Ignore the journey site. That's just kind of a little like, this is what we did, this is why we did it type of thing. It's not really that big a deal. There's two sites that matter here. There's the legacy site and the modern site. So the legacy site is written, and actually this should be an application.cfm, but I couldn't bring myself to do that. Um, but the legacy site basically is written in the old school way, right? So you're setting your page title up here for every page. Now, this is actually, I had someone tell me like, "Oh, no, 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 Mark, you don't understand. We don't, our site's not legacy. We do use abstraction." And I'm like, "Oh, okay, you do? Really? Well, what do you like? Can you explain some of that?" Well, yeah, we CF include our, at the top of every page, we CF include our database access. Just, fall backwards out of my chair, right? Or yeah, we CF include the header and the footer. Those are separated out. Those are separate, and it's like, breathe, right? Like, okay, okay. And listen, I'm not making fun of anybody here, and I'm not judging. I did this. I did this for decades. This is exactly how I programmed from the very, very beginning, right? But like anything, we've moved on. We've moved on beyond this. So let's take a look at like what this page is doing. We've got queries in the top of the page that's going and grabbing things. And by the way, I have so this is actually what this looks like when it renders out. I think, yeah, legacy site. So something to keep in mind here, by the way, um, this all works. And I don't mean that my code works. I'm saying the legacy style works and it gets stuff done. And I hear this argument a lot from people who are like, "Why do I want to change this? This makes me money." I actually had a CEO kind of like go, "Dude, why are you trying to make us like waste a bunch of time doing this in a way that he doesn't understand? It makes me money today. Why should I do this? It works." And you know what? I mean, yes, sure, I cop to that 100%. Like, it works today. It works right now. The problem is not right now. The problem is tomorrow and next week and a month from now and 5 years from now and 10 years from now when you're trying to hire people to work on your site and they look at this and either run screaming out of the interview or just kind of stand there and just, I don't know how is this even working? Like, I don't understand. Where are you doing all of your programming? Where's your like the way that modern programmers think is not this way anymore, right? Um, and that's for a reason because the new way is better. I mean, I'm going to make a judgment there. It is actually better long term for you, for your application, for performance, for growing your site, for everything, for hiring, right? And that's why we do this. So what you'll see here is like there's not really any separation of things, right? You've got like a login and it does all the login stuff in one thing. It even calls itself to log yourself in, right? Um, it it submits stuff to itself to write it to the database. Right? Very common things that I'm sure you all have seen. But again, we've moved past that. So let's just real quick, I'm just going to kind of hop in and show you what this site is doing. Okay, so this is a very common I worked on this for a university. Basically this exact thing I actually worked on for a university, and this is a student ID processing app. So every year, students are asked to, submit any changes that they have to their names or whatever emails. They often are asked to put in a new photo of them so that their photo is up to date, right? And that's kind of what this is, right? So you've got a student intake. I'm just going to put in a number. Oh, I didn't. Let's see. 9. And then I'm going to put in that. And then let's see, where do I want to be? I'll be in film. I'll be in film. I should be in pictures. And my enrollment status is going to be active. I don't know. I'm just going to say that's my photo because that's probably what it is. And I'm going to submit it. So this works. Legacy stuff works. And then if I go here, I go to the admin queue and I log in. Here it is, Mark Tester in film pending, right? All of this is actually, this even filters, right? So it's not like this is a broken, useless thing. It's not. And that's often the argument that you'll get from leadership. Like, well, why do you fix something that's broken? And all of the, like, just have them watch the past 50 minutes is why. Okay, so let's look at what changed in the modern site. All right, so right off the bat, you can see there's a lot more separation of concerns. We've got an API, we've got a place for assets, right? We've got a controller, a model, and views. And I even have some services in here, right? So this is not, and like I said before, please don't do what I did. Don't write your own MVC. The reason I did this is because when you download this and you look through this, you can see exactly how things are wired up. There's not a bunch of like other functionality like there would be if you went and grabbed Coldbox or CFMVC or Wheels. Like those are wonderful, but very complex and functionally rich frameworks that are going to confuse the living heck out of you if you try to go through this and figure out how they're all built. They will help you make your site pattern into an MVC, but you still may not understand exactly how things work. This is a great first step to that. And getting a little bit of a sense of, okay, I see how things are sort of working here. So I'm going to start this time in application.cfc because this is the first place that we're going to see some patterns occurring. So here we are calling some singletons. All right. We've got singletons for errors, results, tables. So these are all things that are going to get called once by multiple places because they're being displayed or used in multiple places, but they're all getting set here. And the reason why is that this allows them to live someplace in a stateless form without any sort of difficulty in finding them in some kind of, place like a CFC folder or something. Like these are going to live and be callable everywhere. They're initializing once and then reusable over and over again. Like I said, they're stateless. There's not anything that's happening that's staying in them. Now let's go to the index. Now you remember what the index looked like in the other one, right? It was, I don't remember, 100 lines, 200 lines of code or whatever, and a bunch of stuff. Let's look at the index this time. That's the index. There's nothing here, right? There's nothing in the index. And you'll find that in most MVC frameworks. Like the index doesn't really have anything directly in it. Why? Well, what was in the other one? Database stuff, models, right? A bunch of HTML. That's a view. So what would go in here? Well, nothing really. So what I'm doing in here is very basically, and by the way, this would be much more complicated in a real MVC, but I'm just calling the page controller and I'm pulling in home. And that's going to bring in, so we've got some initialization. So here's home. I'm calling home. And it's going to go and build my dashboard. It's going to do a bunch of code stuff, right? It's going to use a renderer. And this is calling out to other models, right? I'm not going to go line by line because we'd be here forever. But hopefully you can kind of see the beginnings of the ideas here of how I've taken a thing that used to be all in one place, a big old blob of stuff, and I've separated that out into pieces and parts and put them into places to be used by other things, right? So looking at the models, right? We've got the student repository CFC. We've got the queue. You remember the queue, right? The queue was the thing that had all of the students that were sitting there. And by the way, let's go ahead and oopsie. Sorry, my bad. So this is the modern site. And you can kind of see it's kind of the same thing, right? Looks the same. Looks like the same thing. But it's doing a lot of things very, very differently. One big one, by the way, that is a great example. Let me see if I can pull up the. If I can spell it. So here's an authentication pattern that changed from one to the other. This is a really great and simple example of how you can take something that's kind of a legacy style. So in the legacy style, every single page and everything checks to see if there's something in the struct. Now this is super common, right? This is really, really common, right? In the other pattern, we're actually checking a service. We're using the isAuthenticated service to see if the person that is currently there should be logged in, right? And this is a very subtle difference between the two things, but it makes a big difference when you add them all up. And I'm not talking about like lines of code or anything like that, just conceptually, like this lives in one place and always loads and always exists, right? In that one place. It's going to be in your application.cfc on request. This is in the individual pages, probably at the top, potentially CF included as auth.cfm or authentication.cfm, which I know I did, and probably a bunch of you did that years ago also. Right? Again, submission logic. We've got a payload, we've got a result, right? Here we just send it in using script. By the way, something, and I am almost out of time, I'm so sorry. Something that you'll have seen here that I just want to kind of call out is a lot of times what you're seeing in my like legacy stuff is tag based everywhere, and then in the modern one it's script. So there's a time and a place for tags. Like it used to be that everything was tags, right? And you can do a lot in tags. But I'm just going to kind of throw this out here right now. Unless it's in a view, tags probably don't belong in your application anymore. We've moved past them. A lot of the modern functionality that we're adding does not have a tag-based version of it. And there's a reason for that, primarily that no other programming language out there really, really uses tags, tag-based stuff. It just doesn't really exist, except in places where they're outputting views, right? So CF output, query equals something for doing looping. Beautiful. I love it. No hate. CF set, not that doesn't you shouldn't be setting anything in your views anyway, right? But that doesn't really belong on the outside. The only thing that still bugs me to this day is CF query is just such a beautiful tag, and I love it so much. I mean, I need it tattooed on my body. Speaking of, I should probably get that tattooed on my body. But even I have moved from CF query to query execute primarily to maintain consistency in my code, right? It's not as easy to read. It's not as flexible. There's things you can do in CF query that you can't do easily in CF execute. But if I want to go out and hire a JavaScript programmer and teach them in 3 weeks how to do ColdFusion, I'm not going to teach them tags. They won't know what the heck they're looking at. I'm going to teach them CFScript. So just wanted to throw that out there. You can hate on me. That's okay. So, okay, I've got a couple of questions, and then oh shoot, I'm out of time. But I'll handle the questions. So, Zach says, I am completely sold on OOP. Amazing to call functions, but I have a hard time with MVC. As you can see, it quadruples your code base for a full banking site. That could make sense. But for a simple CRUD interface or even medium-sized app, it just looks like overkill. Zach, I agree with you, and like I said at the beginning, MVC does not equal object-oriented. Those two things are not equivalent. You don't need to do MVC to do object-oriented programming. For simple basic sites, it's totally fine not to have an MVC. 100%. That's totally fine, right? The thing you do have to think about, though, is how big will your site grow? Like if you're just building a site today on a new project and you're greenfielding it, like maybe the site today only has a little bit of functionality and it could be small. If you're okay with refactoring later when complexity rises, then sure, do it simply. It doesn't necessarily have to mean a quadrupling of files necessarily. I mean, in this case, it did. I was being a little bit how do I put it? Pedantic in how I pulled stuff out. Think of it as like a speaking coach that's trying to over renunciate a thing to help you understand it. You wouldn't actually do that if you were on screen and actually saying a thing like doing Shakespeare and doing whatever, right? But during the training, they would have over enunciated. That's a little bit of this, right? Like this could be simplified down. This could be like refactored down a little bit and squashed for your particular reason. So don't take this as this isn't a Bible on how to do MVC by no means. This is more conceptual. Okay, James says, I like the Ortus QB library over query execute. Makes it easy to debug and dump SQL without executing it. Agreed. QB is awesome. QB is awesome. And like I mentioned before, there's a bunch of different tooling out there. Ortus has a bunch of tooling available. There's James, in fact, I'm going to put you on the spot here, buddy. James Moberg has a bunch of amazing code that he puts out that does incredible things. And yes, it does work without having to use ColdBox. So like the QB, by the way, QB stands for Query Builder. That's what that means. And it does run. You don't need to use ColdBox or any other Ortus piece. It just kind of works. It just does its thing. And it's great. I mean, that's actually probably somewhere that we need to, sit our developers down at Adobe and have them really rethink this and maybe add some functionality that helps people build queries in a little bit more of, I don't know, a way that's not quite as black boxy as it is today. I definitely agree with that. And we did when I first started. I actually sat down with a bunch of programmers and tried to figure out whether we should like add tag islands and things like that. And really, at the end of the day, like that sort of fell by the wayside. So I think it's time to revisit that. Do we have any other questions? I'm so sorry. I actually have to go and let my dog out. She's waiting at my other house. So if anybody has any other questions, let me real quick move us to this page. So if you want to get a hold of me, takata@adobe.com. My email is always open. If you have questions, comments, concerns. I'm also on the CFML Slack, so feel free to find me there. My LinkedIn is /Mark Takata. And then, as I mentioned before, the GitHub, this code, it's all up there. It's in webinars, Tremaine, modernizing CF. It's all up there. And then this will be available in the Adobe ColdFusion YouTube. Very important. It's not YouTube /ColdFusion. That's a news site. Yeah, we can't get that back from them. It's Adobe ColdFusion, and I just go straight to videos. Otherwise, you get a video that plays that tells you about ColdFusion. You all know about ColdFusion. Awesome. I want to thank you all for sitting through this with me. I know this was a lot. It was probably a lot of like brain coming out your ear stuff, but it is really, really important to modernize your stuff. I mean, a lot of people are trying to find jobs these days. The first thing I ask them is, do you know how to write modern ColdFusion? Period. Right? It is a big deal with a lot of people. Even if their code is legacy today, they want to move to something more modern. They want to update. They want to upgrade. They want to move forward in their code. They need programmers that know how to do that, right? And if you've just spent the last 10 years doing the exact same thing, get back in there. Constant education. Keep that brain, flexible. Neuroplasticity is the word of the day. And yeah, and we've got CF Summit, CF Summer, should be CF Summer. We have CF Summit coming up in June, end of June. Please come see me. It is amazing. You guys do not want to miss. We're releasing, by the way, the new update for ColdFusion is coming out very, very, very soon at the end of this month, by the way. We're opening the beta up for everyone. We're adding a ton of built-in AI functionality. So the ability to do LLMs, vectors, all sorts of stuff. We've actually had another, we've got a webinar that's being done by our product manager. She's going to teach you how to use all the cool stuff. And at the end of her talk, she's opening the beta up. So you'll be able to grab all of that stuff, download it, start using it, start playing with it. There's a full day AI training that's available for folks at Summit. You don't want to miss that. We're shipping in all of our engineers. You get to learn from the people who wrote that stuff into CF. CF Summit in the summer. Yes. Yes. We totally meant to do that. Yes, we totally meant to go to Vegas in the hottest part of the summer. Oh, wait. Yeah. That's not like you're going to be outside anyway. You can see the Bellagio fountains from your room, hopefully. By the way, we're in the Bellagio this year. Anyway, thanks again. Really, really appreciate all of you coming out to this to come and see me. Got another talk coming next month, of course. Please make sure that you see the talk on AI later this month by Sharvie. That's going to be a really, really great talk. Join our beta when it gets open. Try the new stuff out. It's really, really cool. We added a lot of cool ColdFusionized stuff. We're making it so that doing AI in CF is the easiest way to do it. All right, I'm going to stop the recording and I'll be right back. This is going to pop me out for a second.